Hello everyone, welcome back to my YouTube channel. So there's a good news today that we are starting one more course, a database management system, and it will help you with your placements and getting to know about what software engineering is in a little more detail. So first of all, let's see why we need to study database management system. You might have heard terms like big data, W. So these things, what does this mean? These are the technologies or things that got that were developed seeing the present scenario of too much data, because the competency or the computational efficiency of present computers increased, due to which lots of data was there, and to handle that data, these kinds of technical terms or jargons were introduced. So to get to know about these things, and there are more jargons, I don't want to get too much into detail and confuse you all. So to understand these things, you must know at least the basic of database management system. So what database management system is, how to store, uh, basically how to do the CRUD operations on a data. So don't worry if you don't know what data is, we'll get into the details later on. So basically to do the CRUD operation, that means create the database and then read from the database, update the database and delete from the database. You need to know how to manage the database system, how to manage the database and then do the operation. That's why we need database management system, to deal with too much data that is available nowadays. So first of all, I'll like to give an overview of what all we are covering today. We'll start with basic terminologies. What is data? What is database? What is server client architecture? And this is a little out of the scope for this course, but still I'll explain so that you get an idea, like on high level, how things go on. Then we'll study about what is database management system, and then finally we'll see what is database system. Then we'll move forward to the data model, like what does data model means. And then there are two types of data models, ER data model and then relational data model. Then we'll see a simple example so that you completely get the basic of what does these two models mean and how to deal with this. Then for this lecture we will be mostly focusing on ER model, and in the upcoming lecture we'll be seeing relational model. So for ER model we'll be starting with the basic terminologies. What is an entity, what is a relationship, what are attributes. Then we'll see what is the difference between ER model and relational model. Then we will move forward to see what is the classification of attributes in case of ER model, and then we'll see we'll talk about the relationship in ER model, mainly degree of relationship, cardinality ratio, participation or existence. Then finally we'll see types of relationship, and with this we'll end this lecture. Don't worry if these terms seems a little confusing to you, with time you'll get to know what these terms are, and I'll try to give a brief overview in this lecture so that before moving forward you know at least what exactly you are studying and how will we move forward. So yeah, without any further ado, let's get started. So first of all, with these terminologies, what does data means? Data is nothing but any fact that can be stored or recorded. Now what does this mean? Any fact. By any fact we means that anything that can be stored or recorded. It can be image, it can be text, and it can be audio. You can send a audio message, you can send a text message, you can send an image via WhatsApp, or you can store your image in your photo gallery, any text in your notes app, any audio recorded or call recorded in your thing. Now the data is mostly stored in hard disk. Now if you have gone through the basic of OS, or you know the difference between RAM and hard disk, you might have known that RAM is smaller in size and hard disk is larger in size, and everything that a computer needs is stored in hard disk, from code to data, everything. And whenever a program is called for, like it's clicked, let's say you click on the browser, so its instance goes to the RAM and that particular process run. So what is a process? It's a running program. Don't worry if you don't understand it. I just wanted to tell what is hard disk in general. Okay, so it's stored in hard disk. This we'll get to know more in server client architecture. Now, what is database? Database is nothing but collection of data. Database is nothing but collection of data. Now, you might ask, what is collection of data? Let's say you have an image and there are lots of images in your photo gallery, and you store them like this. They are present in your phone's photo gallery. So this particular thing is database, the database of your photos. Now, you might have playlist on Spotify or any application. You might have downloaded it. Now, this is the database for your audio playlist, right? So now we'll see server client architecture. So I'll erase the board. Now, what is a server? Server basically means, let's say you are talking, you are just using ChatGPT to get your answer. So what you are doing is, you are sitting on your, you are using your laptop, your mobile, to interact with ChatGPT. Now ChatGPT has its servers in US. So what does server means? Server means the computer that has server code, server program or server code. Now, what does server program or server code means? Now, in case of ChatGPT, it will be your LLM, large language model, or any backend of your ChatGPT. So these kind of things, or even database. Database will also be there in your server, because let's say you were trying to retrieve the older chats. Then what the server program will do is, it will go to the hard disk and ask for the data. So what the server do is, it stores the data and also the programs or models that are needed in order to respond to the request given by the client. Now, what does client means? Client means the computer that has client code. Now, you might ask, what is client code or client program? Now, if you're interacting with ChatGPT, you might be using your browser, let's say Safari for iOS people, and Microsoft Edge or Chrome. So these browsers, or you are just using ChatGPT in here. So these browsers are nothing but your client code, and this will be your client, right? And this server will be serving millions of clients at a time, but this client will refer to just one server at a time. I know this might seem a little, on the wrong side, because you might be referring to two servers or more servers at a time, but for a particular application, you will be referring to just one server. Okay, and now client will be anything: your laptop, your mobile, your PC, anything. Now, coming to next, what is database management system? Now, to manage these data, and then retrieve the data, create the data, update the data, you need a code. Because your data will be stored in your hard disk. As I mentioned, you have a CPU, then you have a RAM, and then you have RAM, and then you have hard disk. So this will be having your data plus server code. Now, when the server, the developer will call this particular program, so that server starts running, this server code will move here. It will be stored in the RAM. Now, the data won't move here. Data won't move here because you might have large amounts of data, and also you might have the data stored in more than one hard disk. So the data will remain here. But this server will do is, whenever the client gives a request for data retrieval or creation, what the server will do is, it will go to the hard disk, see the data, and also check. It will authenticate whether this the client that is accessing this data have the access to this or not. Then if the user or the client has access to this particular data, it will give back the data in the required format. Whether you want to create, it will store the create, you will send a request and then it will store the data here, it will update the data, or it will just give you the data back if you want to read the data. Okay, now this code, how to manage the data, how to manage the data is basically your database management system. So this is nothing but the database code. I mean, the code that is dealing with database is your database management system. Now, what is database system? This is nothing but your database code plus the data that you are using. Just keep this term in mind. You won't need it in coding, I mean, in practical purposes, but you might have to go through these kinds of questions in interview. So just keep this in mind. Database system is nothing but database code plus data. Okay, so now we'll move forward to what is data model, and the two types of data model that are there. ER model, entity relationship model. ER model is nothing but entity relationship model, and then second one, relational model. Now, what is data model? Data model is nothing but a model which is used to represent data structure or data structure in database. Now you might get confused with this particular term, I mean definition. So what does this mean is, you want to store the data. Now to store the data, like to create a website, a front-end website, the front-end developer must know how to get the data, whether he needs to get an email ID for the person to log in or sign up, whether he needs a phone number or something. So these things, how the data will be stored in your database is basically, I mean, the structure of the data present in the database is managed by data model. Now these two kinds of data model are there. ER model, I'll just erase first. So ER model and relational model. Now ER model is entity relationship model. Don't worry if you don't understand these terms, we'll study it here. So ER model is basically diagrammatic representation. What does this mean? This means that we will be dealing mostly with diagrams in this particular model, and here we will be dealing with lots and lots of tables. Tables are also known as relations. Don't get confused with relations and relationship. These two are different. Relationship here is different from the relation here. So don't get confused. Don't mix things up. Okay. So let's see a simple example so that you get to know about ER model and relational model in detail. So let's say we have a teacher and who teaches students. Now teacher, let's say you want to store this is ER model. Let's say you want to store this in your database. What you need to know is teacher's ID, I mean the joining ID that the teacher has. Similarly, student will have roll number, or student ID also you can say. And also teacher will have name, teacher will have name, and teacher will have age. Now student will also have name, student will also have age. So basically this is the representation of ER model for a relationship that teacher teaches student. So this is a relationship and this is represented using diamond symbol. This is teacher and student. So these are called entities, teacher and student. Don't worry, I'll explain what is entity. And these are attributes: name, age, teacher ID, roll number, name, and age. These are the attributes of teacher and these are the attributes of student. Okay, so this is basically ER model. ER model on the high level depicts how the database, how the data is stored in the database. It doesn't give the details. It just says that teacher is there, student is there, these all attributes are there. It doesn't tell who all teachers are there or who all students are there. Now in case of relational model, let's see an example. Let's see this example only. Let's say I want to convert this to relational model. Now keep that in mind. This will be forming, these two things which are a part of this relationship will form two tables. So let's say if there are three let's say entity or object are there, then three tables will be there. Whenever you are asked to convert ER model to relational model, first thing you need to do is take these two objects and make a table. Teacher, please forgive me for my writing, and student. So these two tables will be there in our relational model, and we will have name. First we'll put ID, name, age. Okay, and this we will put student roll number, name, and age. Also this relation, for now just ignore it. When we are converting it to relational model, we'll see how to depict this particular relationship in this, but for now just forget it. Just think that there are two tables which are there. So in case of ER model, we will be just storing it as a diagram, but in case of relational model, we will have values. We will store, okay, first ID number 1, let's say Bob is a teacher and his age is 42. Then Seema is a teacher who's and her age is 40. So these are the teachers which are there in a particular school. So in this we are storing the instances. In this we were just storing the diagram, but here we have the exact values. And now let's say roll number 1, her name is Ram and age is 10 years. Then Sham, age is 12 years. So this is the relational model and this is your ER model. Okay, so I hope it's a little clear now. If not, don't worry, we'll study these two in detail as well. So now we'll see the basic terminologies of ER model. So today we will be focusing mostly on ER model only, and in the next lecture we'll see relational model. So what is an entity? As we were saying that teacher is there, student is there, and this relationship is there in between teacher and student. The teacher teaches the student. So these two are entities. These two are entities or objects. Entity or object. So these two entities or objects which are the part of the relationship, these are there. Now this is a relationship. So basically, just for definition, you know what an entity is, you know what a relationship is, also you know what attribute is. I told you, right? Name will be there, ID will be there, age will be there. Now for student, name will be there, roll number will be there, and then age will be there. So this is entity, relation, and attributes. Attribute you can think of as it as properties of an entity. So now we'll see the difference. Also, before going to the difference, a few points to note that relational model gives you lots of details as compared to ER model. We saw that right, tables are there in which we got to know what all values are stored in that particular thing. Now, in practical purposes, this might not make sense to a lot of people. Why? Because this representation, it's bit easy to represent. I mean, it's a bit easy to interpret, but uh, for a developer, it's not that useful because we can't store data here. We are just representing it. It will be easy to interpret, and it will be making sense for a developer on the higher level. But on the lower level, how to store the data and how to manage the database, this won't be that helpful. So relational model will be used there, where that particular developer will be storing the entities, I mean the instances of the entity in much detail. So that will make more sense. Now let's see the difference. This is basically a structure of a database. Now let's see the difference between ER model and relational model. Now ER model, also this is just the association between the entities, and entities are just that they are like they are I mean, how to put it, uh, they are just participating in the relationship, you can say, and these are the objects which are a part of the relationship. Okay, so difference ER model and relational model. So first point is that only few details are there. Just now I said only few details, and in this all the details are there of the database. All the details of database are there, and there only few details are there. Second point, easy for naive person to understand. Let's say you are a product manager. Now you won't need to know what all values are there in that database. You just want to know a brief diagram of that database, so that you can make the I mean your stakeholders you can make your stakeholders understand what all is there. So it is easy for naive person to understand. Now this is comparatively difficult to understand. So this will make more sense for a product manager, and this will make more sense to a software developer. So keep that in mind. This is mostly used to interpret the what all is there in the database, and this is just everything that's there in the database. So now this is done. We'll see how to classify attributes in the ER model. Now we'll see like the properties that were there for ER model, but how many ways are there to represent those particular properties for a database. So I'll explain. Yeah, so attributes, as we know, these are the properties of relationship. Okay, so let's see the classification. This, so first is simple versus simple versus composite. This is the first classification of attributes. Simple, that means which cannot be divided further, and this can be divided further. Now you might ask, what does that mean? That means that let's say you have age. Age is just a number, right? And it cannot be divided further. So this is a simple attribute. And composite means, let's say you have name, and it can be divided into first name, last name, middle name. So this is a composite attribute. Now coming to second classification, single valued versus multi-valued. Now again, it can have only one value. It can have multi-valued. It can have multiple values. So again, age. A person can have only one age, right? It cannot be like the person is both 15 and 30 years. So it is a single valued attribute. But for multi-valued, let's say phone number. A person can have more than one phone, or let's say SIM cards. So this is a multi-valued attribute. Now coming to third classification is stored versus derived. Now what does that mean? Stored means that the attribute which is stored in the database. That means that we cannot just calculate the value of that particular attribute. Let's see, stored versus derived. Now what I told you, right? It is stored in the database as it is. That means the client or the user will give you this detail, and you cannot just assume something. Assume that this will be the value of this attribute, the stored attribute for this particular client, and this can be derived from given data by the client. Now let's see an example. Let's say you asked the client to give year of birth of that particular client and current year we know, right? So this year of birth is a stored attribute, but let's say we want to know the age of the client. We can simply use the current year and minus year of birth. So this is a derived attribute because we have derived this particular value from the already present data. Now coming to next classification, it's just one thing, complex attribute, which is nothing but a combination of multi-valued plus composite attribute. Let's see an example. Let's see this address attribute. Now the address can be multi-valued. Also the address can be divided further: floor, room number, again building, area, pin code, etc. So this is both multi-valued because your current address, your residential your permanent address and your current address is there. So it can be multi-valued, also it can be divided further. So this is a complex attribute. Now coming to relationship, we will study relationship in greater detail. So we'll see what does degree of relationship mean, what does cardinality ratio means, and what does participation or existence mean. Okay, so as we know, relationship is nothing but association between the entities. Now degree means number of entities participating. So in our previous example, teacher teaches student. This was the example, right? I'll try to write more clearer from next time onwards. So here only two entities are participating. So this basically means that degree of relationship for this particular database is 2. Now you might have one more thing, principle here. I know it might not make sense for this particular example, but for an instance, let's say these 3 are there. Now in this case, the degree will become 3. Now what is cardinality ratio? So cardinality ratio, it's defined between the entities. And what does this means? Ratio of, first I'll remove this so that you don't get confused. So what does cardinality ratio mean? Cardinality ratio, it is just the ratio of maximum number of relationships that an entity can participate in. Now, what does that mean? Let's say that a teacher can teach at most 10 student, and a student can have at most one teacher. So in this, the teacher can participate in n relationships at most, and student can participate in just one relationship at most. So the ratio of maximum number of relationship that an entity can participate in is nothing but the cardinality ratio. So the cardinality ratio for teacher and student will be, now teacher can teach at most n student, and student can have at most one teacher. So for teacher and student, cardinality ratio will be n:1, and for student and teacher, cardinality ratio will be 1:1. Student can have at most one teacher, and teacher can have at most n students. So this is cardinality ratio. Now coming to now the thing that the condition that was there, that a student can have at most one teacher and the teacher can have at most n students, is nothing but requirement analysis. Now what does that mean? That means that there was some requirement of the database, and the developer analyzed it and put it in one condition, that okay, I need to design a database in such a way that a teacher can have this and a student can have at most one teacher. So this is nothing but requirement analysis, and this condition is the result of it. Okay, now coming to participation or existence. Participation is based on minimum number of relationship an entity can have. So the cardinality ratio was based on the maximum number of relationships an entity can have. Now coming to minimum number of relationship. So let's say that there was again teacher student, again coming to teacher student. So let's say a student should have at least one teacher. Student must have at least one teacher, but a teacher can have 0 student under her. Let's say a teacher is there which is not required right now in the school, and that teacher doesn't have any student under her or him. So in this case, the student should have at least one teacher, but the teacher may or may not have a student under him or her. So this means that participation of student is total participation. Total participation means that every student will be participating in the relationship. Let's say this is the teacher and this is student. So every student will participate, but a teacher may or may not participate. So a student is having total participation, but the teacher is having partial participation. Total participation is depicted by double lines, and the partial participation is depicted by single line. Now we'll see types of relationship. Now what does types of relationship mean? This means that there are many ways a relationship can be there in the database. So the relationship can be in a way that student and teacher, again studies, because here we are representing it this way. So studies from teacher. Okay. Now it might be the case that a teacher can have at most m student, a student can have at most n teachers. Now because there are n teachers, there are n teachers as a total in the school, and there are m students as a total in the school. So a student can study from all the teachers that are there in the school, and a teacher can teach all the students that are there in the school. So a student can study from at most n teachers, and a teacher can teach at most m students. So this is nothing but many to many relation. Many to many relation means that there is no condition that a student can study from one teacher and a teacher can teach only one student. So this is many to many relation. But in opposite, if I do this, that a student can study from only one teacher and a teacher can teach at most m student, this will become many to many, sorry, many to one, this way. And if you think of it as this way, that a teacher can teach at most m students and a student can study from one. If you see from this way, like the relation from student to teacher is many to one, but from teacher to student is one to many. So keep this in mind. And also, if I put the condition that only one student can study from one teacher and only one teacher can teach one student, only a teacher can teach only one student, then it will be one-to-one relation. So these are the kinds of relationships. So no, it's not relation, sorry. This is all the kinds of relationships an entity or entities can have. Okay, so let's see an example before ending this lecture. We'll see an example which will make things clear, both degree, cardinality ratio and participation. I'll urge you to write this example in your notebooks so that you don't forget it further. Now we have just the requirement analysis. For this particular problem. So it says that a student can study from as many teachers as he or she wants, and teacher can teach as many students as he or she wants, and there are m students and n teachers in the school. Now I want you to tell me what is the degree of this relationship, what is cardinality ratio, and what kind of participation we can have. So first of all, let's draw an ER diagram. So student, sorry, we'll put teacher here so that the confusion is not there, and then student. So nothing is that a teacher can teach at most m student, and a student can study from at most n teachers. So first of all, what is the degree? Degree is nothing but 2, because only 2 entities are participating. I forgot to put the relationship here. So now coming to cardinality ratio, I want you to pause and think what can be the possible answer. Now, cardinality ratio from, teacher and student. Now, if you see that a teacher can teach at the most m students, so it will be m is to n, because a student can study from at most n teacher and a teacher can teach at most m student. And for student and teacher, it will be n is to m. Now, one thing, can you guess what kind of participation it should ideally have? So ideally, it should have partial participation from both the sides, because there is no one-to-many, one-to-one relation in this case. So it's highly likely that the relationship will be partial relationship only. It can be total participation from one side or both the sides, but it's highly likely that partial participation will be there. So to sum up, the entity is represented using square symbol, the relationship is represented using diamond symbol, Attributes are represented using oval symbol, total participation double line, partial participation single line. So this is all from my side for this lecture. If you have any doubts, please do let me know in the comments. I'll reply and sort it out as soon as possible. And see you in the next lecture. Till then, keep practicing of these things, and you'll get to know these things as early as possible, and you'll be comfortable in the upcoming lectures. Thank you. Have a nice day.